All right. So we are still on data clustering. I remember that we did mention that data clustering in the field of machine learning or data science is the process of grouping values based on the specified criteria. And the criteria we have adopted is based on the behavior of the values. Remember that we cited a real life scenario where we use the sales data set and we wanted to cluster customers based on their purchasing what? Behavior, right? Good. Now, as for us as data scientists, our goal is to be able to group our data values, which at the end of the day, I told us that we are expected to interpret the clusters, right? Okay. And that interpretation is what is key when it comes to decision making. So like, if I could just look at the last interpretation, don't know if it was here, the interpretation of that analysis, was it here? After clustering, let me see, we are able to know students who like reading books, right? But I'm wondering, I'm not saying that. I know we complete. But you have it in your own, right?
You presented in a PowerPoint and then.
Okay, I use PowerPoint.
Yes.
Okay, I use PowerPoint for my. Okay, so but you have it there, right? Okay, so. All right. So at the end of our cluster, we were able to arrive at, recommendation after interpreting. I remember that I also mentioned that data clustering can help a business organization to know how to place their ad or how to run their ad, because then the clustering will have exposed the particular audience, right? They should target. So you can see that from that class, it's actually a real life application. So it's not just abstract. Okay, so let me open the slide so that we'll know exactly where we stop. Please, I want us to identify this together. So we have to look at the cluster centered. We have done this, right? Trying to pick up from where I stopped last time. Note, the more the numbers of clusters, this was one of the advice I give to us, the more is what? Difficult to interpret. Therefore, let us, what did I specify here? I think, am I correct with this, or is it typographical error? Therefore, let us, there's a statement here. Let's data frame in order to use heat map. Okay, so I'm trying to, okay, we have not, have it? Whatever here. You check your history should tell us where is that the last command you ran. Please, let me see. To view clustered. We have not done this.
We did this where you told us to try.
Okay, let me see from here. In your own notebook, is this the last command you have there? df_clean. Is that the last?
No.
What do you have there?
The last command I have is kmx2.cluster_centers.
So I'm wondering, maybe this was not the, okay. Is this one, right?
Yeah.
I can see kmx2 there, right?
Yeah.
But did you have this analysis? Do you have it? where we outputted the cluster labels.
Cluster label, yes,
you have this one, right?
Yes.
After it, what do you have? I have concatenating the series data and the main data set. That is that particular output. Here we added this one and the other data, which is this. So this is the clustered output, while this 1, 2, 3 are from the other data.
Okay. What happened was that you know, from the PowerPoint.
I was asking a question. Okay, so this is where we are to start from. Looking at what the mean of each column before the interpretation. But I was thinking we have done the interpretation. We have not, right?
No.
Okay, so look at it here. To view the two clustered again, which you confirm that we have done, right? So this should be the next one, right? All these, we are still under the explanation of those codes that we put together that give us the 3D graph. Okay, so let's quickly apply this one. Let's apply this. So to quickly look at the mean of the column before we interpret, let me switch to my development environment. So I understand that we changed some name that day. Let me see if my own is still data. It's still data, so I'm going to the code. Where do I have data? Okay, so this is it here. This is it here. Hope I have, because I know I changed some name based on, let me see, so I can get it right. So I will find out by the time I run it if that data set name exists within the data. So like I said, looking at the mean of each column. So simply just do data dot mean. It means, yeah, it means it exists. I have data as a data frame name. When you type your own, what do you get? Let's see if we're on the same page. Now you can see what happened. I just typed mean instead of recognizing it as a function. That is why it displays like this. So what I would have done is to, instead of seeing it as just an attribute or a property, I will recognize it as what? A function. Good. So this is exactly what we have in the slide. Hope you have also confirmed your own. Yeah. All right. So now let me go back to the slide. So here, looking at the mean of each column, that is one we just did now. But, okay, yes. So here is looking at the mean of each column before interpretation. So this is exactly what I just outputted now. Now, this is our interpretation. What is our interpretation at the end of our clustering? We discovered that what? The students that are in cluster 0, they are non-what? Readers. These are people who does not, how do you see? Look at it here, book. You can see the mean is generated 2.9 compared to the next category, 4.5 points. So that is the reason why we are saying that, okay, they are classified under what? Cluster what? 0, which we have now interpreted as what? Non-readers. Now, the students that are in cluster 1, entertainment what? Enthusiasts. So these are students that have interest for entertainment. How do we know? Based on the number of TV show recorded, right? Then the number of what? Video game they also what? Played. All right. So that is what gives us the insight Now, remember that to the organization, to the company that you are going to present this, your insight to, it will guide them in probably marketing this category of what? Item to them. Good. Now, let's look at visualizing clustered centers. So this is a new topic now. So where this one that I just explained now, that is the end of the explanation of the graph. Now, remember that we said that when you are clustering your data, the factor for clustering is how closer the centers, the points of the value. So that is why, if you remember when we started, I was prompting us different graphs where some of those data points were distant from each other. At the point they were together, at the point we started what? Pulling them to different what? Aspects. So which means that the factor here for our clustering is based on what? Their center what? Point. The distance between one centroid to what? Another centroid. Good. Now we are saying that we can better interpret it if we visualize it based on what? The centers. That is the meaning of what? Visualizing cluster centers. Now, visualizing the cluster center in cluster centers in a heat map. So here we are introducing another concept instead of using a 3D what? Modeling graph or visualization graph. We are using heat map. And then you are going to see how the heat map will help us better to identify the centers. Now, this is the code we are going to run, as we can see. So just to explain first before we go to the notebook to implement it. So at first, we are going to view the centers, the cluster center, by writing what? K-mean what? 3. Now, this particular one that we are using for the example, we are having what? 3 what? Clustered, as against what? The 2 clustered before. So now, the 3 clusters are what we are seeing here. This is 1, this is 2, this is 3. Okay, so this is what the heat map can easily help us. Now, in case you cannot interpret with the other 3D graph, this is another word option. Good. What matters is that what helps you to present your interpretation. Good. Now, here, so this is the outcome of it. You can see the 3 word cluster. So the next line of code will be view the cluster center in a data frame. Because here, you only view them as an array without attaching the headers, right? Or viewing them in the real data frame. So here, we add the column. Remember that we use this data frame as a function so that it can be captured as real data. So the difference between this and this is that this one, the headers are displayed. And at the same time, you are able to what? To detect their central. Now here, view the cluster centers in a heat map. So this is the code that generated what? This graph. So just to explain it, we imported Seaborn. Remember that Seaborn is one of what? The library for plotting, right? And we represented it as what? SNS. Now, we now concatenate the library with the what? The heat map what? Function. Then the whole of this is your cluster data, where you did the 3 clustering. Then you comma. Now this C map, if you can still remember in our last class, I said it is used to control the color.
Yes.
So this is what defines what? The color. Why this one are notes equals to true is the one that display the values on top of what? Each of these boxes. So if you remove this now, you will have this graph, but the values will not be what? Written on top of them. Do you understand it? Good. Now let's quickly go to our Python notebook now and start implementing the heat map. So the first thing we are going to do is creating key mean word model for 3 word clustered, like I said before. Are you with me? So now let me go back to my notebook. Using comment to explain it. Let me see if I can increase a little. Creating k-mean model for 3 clustered. So we will simply remember that we must have imported which of the library? sklearn, because we have added it to this notebook. That is why we are not bothering with all that, because these functions are sub-functions under what? The sklearn. Good. So now we will just continue with what? So I will save it as an object so that I can reference it. So which is what? K means what? 3. Then equals to, then K mean function. Remember that is case sensitive, right? Capital letter K and capital letter what? M. Good. Then, and then S, we open the bracket. So we specify our clustered number as one of the arguments or parameter we are supplying, which is denoted with what? N underscore what? Clusters. Clusters is part of what we have explained before, equals to what? 3. The one we did last time, we put what? 2, which means that this is where you determine the number of K, right? Remember I said then that the K represents what? The number of what? Cluster. That's what the number of group or segment. Good. Good. Now, comma. Then the next one is where we specify the number of what? Initial. So I'll say N underscore inits to represent that. And then we set the value to 0, right? We set the value to auto rather. To auto, we set it to auto. Then comma. Now, each time you run the code, we don't want the number of clusters to what? To change. So I told us that to make it fit, we put what? Random, right? Random underscore is an attribute state. So this one is to prevent it from what? Changing each time you run your code, so that the clustered value will not change, to make them fit. And then we set it to what? 40 which is the standard. Now, if I run this now to see, so that has been confirmed. So the next thing I'm going to do, I will now transform using the fit function. Remember, FIT, the one that will transform, the one I said that will calculate the mean, the average, right, of the values in each of the what? The column across the data you are transforming. So to do that, the reason why we save this as an object, because we want to attach that transformation function to it. So I'll quickly start by saying what? K means 3 dot fits. Okay, you should remember this. Then supply the name of the data you are transforming, which is what? Data. So just in case you are here to understand the configuration, look up here. The whole of this, an action will have been carried out here and stored in what? This object. Now, which means that as you call kmean 3.fits, you have automatically what? Called the whole of this, right? So the result this will have generated is what you are concatenating with what? Is what you are building the fit function on. And then you supply the data is to transform. So if I run this code now, then it produces what? A calculation has been done, which is what? The mean. So if I want to view, then I will use the label. Remember, I will use what? If I want to view the mean, I will just say what? K mean what? K mean 3.
That's M.
That is F. K mean 3, right?
K means.
Okay, K means 3, then dot. And I said what? Okay, K means 3. Okay, S3, right? Then dot. Remember, I said that we can display the label. You should remember what we use. we use a label underscore, right?
Yes.
Label what? Underscore. And then when we run it, that is expected to display the value. Object has no attribute what? Label. I think it's labels. Labels. So you can see it now. So this is what actually generates what? The array. This is where you can view the clustering that must have happened.
Yeah.
You remember I specify what? 3 clustering, right? You can see 0 as one of the what? The cluster. You can see 1, and then you can see what? 2. So let me allow you to get here before I proceed. Okay. So we. Okay. All right, so we have just applied this. So I was trying to explain the calculation that must have happened. So we need to know what happened at the background or what is happening at the background. When you run this .fit on the data with the k-mean objects, what happened? It calculates the what? It gives you, it calculates, it uses the average, the mean, to group them into what? Different what? Clusters. And that was the reason why we got this, where we displayed it. So the next one is, I believe, is the one that I've already explained. This one I just explained now, right?
Yes.
Okay, sorry. This one I just explained now. So this is the one I have already implemented in order to display what? The clusters values, right? Or representative. So this is displaying it as array, not in the data frame. So now the next one is that we want to also look at the clustered what? Centroid. We want to know the center, because that is going to be the basis for the heat map. Okay, the heat map is going to be based on what? The centers. So let's run this code. That is what? To look at the center or the cluster center. To look at the cluster center. To look at the cluster center. So simply run. Let me use comment here. Now, let us see the clustered centers. So, which is going to be k-mean 3, right? So this is another attribute, just like that label. Another attribute, because this is not a function, it's an attribute. So now is clustered, cluster underscore what? Centers. Then underscore. So if I run this, so just to interpret this, what has happened here is that under clustered 1, that is what the headers in the particular data you are working with. The middle number under each of those columns. The middle number, that is the center number of each of those columns, is what you have here. So you can have 1, 2, 3. Which means what? This is what? The center number for all the clustered what? 0. Then here, clustered what? 1. And then here, clustered what? 3. Or 2 rather, based on our clustering binary number. Do you understand what happened there now? Good. Now, the next is what? Note, the more the number of what clustered, the more is what? Difficult. So this is like an advice. So whenever you are running, you are clustering your data, you are advised not to use too many what? Cluster. If you want to give precise what? Interpretation. That is what I'm saying here. So to interpret,
Therefore, let us display our data frame in order to use what? Heat map. So the concept here is that where you feel that the number of clusters based on the other one is difficult for you to interpret, then use what? Heat map. If you use heat map, even if there are many, you'll be able to what? Easily what? Write your interpretation. So this is me trying to make you to know the reason why I'm bringing heat map. Because if I'm working within 2 clusters, I can easily use what? 3D graph, right? To visualize it and be able to interpret easily. So once it exceeds 2, because cluster usually start from what? 2, like I told you the other time. Once it exceeds 2, you are advised to use what? Heat map. Exactly. Good. So now, if we want to use heat map, so now we want to frame. We have to put the data in a proper what? Frame. We have to frame the data for heat map application. You cannot pass it into heat map just the way it was displayed as what? Data array. So for us to frame it, that is the next step now. So now to use heat map function to present the clusters. Frame, or let's say what? Puts the data in data frame. So how do we do that? We simply say what? PD dot data frame. Remember that what? The D should be in capital letter. I believe you understand that, right? Data frame. Then the F is always what? Capital letter as well. So it's a function. So what are we passing? Which data are we framing? Is the K-min3. So I will supply what? The K-min3. Control C. Come in here and paste. Okay? K-min3 dots the cluster centers. Cluster underscore centers, which is the one that generated what? This particular information. So what we are actually framing is this. This is what we are framing. So we cannot pass this into what? The heat map until what? We frame it as a data frame. So that's why we are using what? Data frame. And we are supplying this as one of the what? The inputs. And then we are joining what? With this function that must have what? You know, as the factor for, remember we are using what? Center, the center point. So if I run this, it's going to what? Output. Okay. Underscore after what? Centers. Okay, good. Thank you very much for that observation. So if I run it now, so I have it in a proper frame. I have it in 2 dimensions. You can see this display. This one is just like array. This is not data frame. Now you have framed it. It's like you have repackaged it as data. Now we can send it into what? Into the heat map. Exactly. Yes. Let me allow you to, okay, you have already applied that. Okay, good. So now let's go back to, so the next thing is what? Now we want to add the columns. You discover that after framing it, the headers in the data set were not displayed, though the data was framed, but the headers are missing. And that is why when the headers are missing, what you get is that what? they will be represented with the clusters rather, the clusters. Remember, we have 3 clusters, right? This is what? 0 what? Cluster, and these are the center value in each of what? This particular what? Cluster. So this is what? 1, this is 2. But what we want is that it shouldn't be represented with number. We want to substitute this number while still using this value with the right data set what? Headers. So that is the reason for this. Because what we did there, we just display, we did not store it as an object. And again, we did not add what? Column. So you can see what we are bringing in here. We first of all save the whole of that output as what? Clustered underscore what? Centers 3. Then we are also supplying what? Column attribute in order to add the what? The column instead of what? The cluster label. Do you understand it? Good. So let's quickly look at that.
If you don't mind, I'd like to ask a question.
Okay, answer.
Going back to where we have the cluster,
okay,
where we got the label, where we ran the code and brought out the label.
okay, here, okay.
Yes. Yes.
To go up.
So, okay, come down. Yes.
Here.
Now, all these clusters we have here, the 0, 1, and 2. Right?
Yes. Yes.
For the 0, for example, does it mean it is everything that is closer to 0? That is given, that is attributed to
0.
a particular cluster 0.
Not really, but let me just take us back to when we started.
Okay.
Remember, I cited a scenario so that you picture it well. Because sometimes, if you cannot really relate the application of this in real world, you might be confused. Now, where I said, for example, you have different branches with in different locations, different sizes of what? Shops. Then if you want to cluster them, you can cluster your company branches based on what? The size, or based on what? Transaction. Now, which means that what is represented here as 0 is a cluster, is a group. What is represented as 1 is another group. 2 is another group. Now, the question you should be asking is that what determines grouping certain value in 0 or as 0 and what? 1 and 2 is the centroid, the center, the distance. I mentioned it. So here now, the criteria for grouping, for clustering into 0, 1, 2 is based on the distance. That is why the first graph I was showing us, you notice that at some point, they were far from each other. Then as we started running it, I said that you run it repeatedly, remember, until no more changes. So which means that what the criteria for grouping or clustering is based on how far they are from each other. So which means that if it is sales inventory now, for example, now you recorded a sales entry 500 naira. You record another customer what? Purchase as 1,000. You record another one 2,500, another one 3,000, another one 5,000. So if the now says you cluster them now, that means you'll be clustering them based on what? The difference between 500 and what? 1,000. So all the record within 500, 600, 700, 800, before you get to what? 1,000 will be in one group. Now you now start from 1,500, 2,000, 2,500 in another what? Group. So it is the Python that is doing that on its own for us. Instead of us to have been doing the manual. Good. So now, which function is Python using to calculate this what? Centroid or center is what? The mean, the average. That is what is adding the values you have in the column, right? and what? Dividing it by the number to arrive at what? The closeness. Is that clear now? So this 0 now is just like a group label. Good. Now, let's go on. I think I was talking about adding the header, right? The column to the data we just framed, right?
Yeah.
So let's go to our notebook. So here is now let's add, let's save first. Let's save the outputs. Now let's save the outputs as data frame. And also, so we are going to do two things at the same time. Also add the columns names. So two things we are doing at the same time. So to achieve that, I'll start by saving it as an object, and the objects should be or can be center underscore centers 3. I'm just using this equals to I'll copy the whole of this. I'll copy this. You understand? This is what generated the data we are saving as an object, and then I'll paste it here. So the only thing I will add is the column, and this is where I'm adding the column, comma. So I'll simply say what? Columns equals to the data itself. Where are the column coming from? That is what you are extracting the column from a data, and then concatenate the column. That is what you are picking the column from this particular data set. That is what it means. Do you understand it?
Yes. Yes.
Good. So now, if I run it, I have it acknowledged. Now to see the value, to see the data frame, I will just call the data object, which is this, and then run it again. So I get, now you can see that I have been able to what? To substitute my headers. I have changed the 0, 1, and 2, which were the cluster label, just because at that point, you have not specified what? That it should be replaced with what? The headers in the data set, called what? That data. Is that clear? Okay. So now let's go back. So the next thing is where we want to bring in what? The heat map now. Now that the data is in a proper what? Frame that we can use to plot what? The heat map. So now let's put the cluster into what? The heat map. So here we are going to import what? Seaborn as what? SNS. So Seaborn is a library, like I told you before. We already have it. So since we have already have it, so you can go ahead and implement your own now. So just to reinitialize it, it will call for any alarm. So here, now the data is ready to be put into heat map. To be put into heat map. So I'll start by importing, that is if you have not done that before, Seaborn library as SNS. So let me confirm that. Okay. So the next one, I'll say SAN SNS rather, heat map. Then, which data set are we giving to the heat map? The one we just created now, which is what? This. Control C. And then I will simply what? Paste it here. So if I run it, I have my heat map generated. So let me wait for you. Are you there now? Okay. Now, there is something that we need to observe here. When you run this, it's showing you what? As is, as an error. This as is because you did not end the code here. Just put semicolon and run it again. It will remove what? The as is and give you only what? The heat map. Do you get the same thing? Good. So now you can see that the three clusters are fully represented. This is what? Cluster what? 0. Remember that your endpoint is interpretation. The reason why you are doing this so that you can easily interpret. So we are still going, you see how we'll be able to interpret it now. So now going back to the slide, I want to change the color. Remember the default color is this, right? Now this color will not actually help me to easily do my interpretation. So I need to what? Change the color. To change the color, to update the color, add what? CMap what? This. Which I told us the other time that what? There are other color package which is researched the other day. So you can as well research in case you need different color name, right? Just research on what? CMap what? Color values, right? So in case you now want to use this set of colors. Now, let's quickly can I proceed? Okay, so now the next thing is for us to update the color. Let's assume we are not okay with that color. So this one is not compulsory, right? It's just because we are learning and we want to know the function of these attributes. And in case I am finding it difficult to interpret based on the color it came out with, you have the privilege of what? Updating the colors. So let me quickly go back to my notebook and use comment to explain. In case you want to update the colors, in case you want to what? Update the color, use see what? CMap equals to CMap equals to, which value did I say? Capital letter what? R, letter D, capital letter B, and then what? U. So let's quickly implement that and see the outcome. So I have it here already. I think what I will do is just to what? Just to update it here, right? Let me just update it here. It's another attribute. So I'll just put what? Comma before I introduce it. Okay. So I will just say CMap equals to, and the value should be R, D, B, U. Now let's run it again. Perfect. So in case you are able to research on other values and you get a value, then you can put it here and then see how it will change your colors. Hope we are on the same page, sir. So what we did here is what? We added a note, right? A note in order for us to display the values on the boxes, because seeing the value will assist us to come to write our interpretation. So here, this is our interpretation, sir. Final what? Interpretation. What do you observe from here? 0 is what? Non-what? Readers. Because remember that we are calculating this based on books from where we started from.
Yeah.
Then 2, entertainment what? Enthusiasts, which align with when we're using what? When we're using two what? Clustering, right? The third one is what? Prefer what? Video game. Prefer video game. So how do we know this? 0. This cluster 0, right? Look at the value of book. Very low. These other two now, they are for both game and what? TV show. Then if you check here now, in cluster 2, which is the third one, right? Compare this value. Can you see it here now? 0 and what?
3.
Good. Now here, so you can see that what? They have higher value here. Under what? Cluster 3. Prepare what? Video game. So finally, that is the interpretation. Like I advised us the other time, it is the interpretation that matters. Before getting here is for you to know how to see the variable for your interpretation. That is why you are going through clustering, using heat map or 3D what? Graph to visualize so that you can interpret better. Now, this is an assignment. This assignment is structured to take you through everything we have done under what? K-mean what? Clustering. Remember I said there are 3 techniques for what? Data clustering in data science. The first one we mentioned was what? Sorry, there are 3 data modeling techniques, right? The first one is what? Using clustering method. So we have come to the end of what? Clustering. Now remember, there is another one I said what? Hierarchical. And there is another one we have what? DB scan, right? So this assignment is to bring us to the end of what? The first what? Data modeling what? Techniques, which is what? Clustering. So write the assignment.
You see the previous interpretation.
Okay, here, right?